These are the answers for the Exo and Endo thermic exam questions, the foundation tier. So question 1, this question is about compounds of oxygen. The reaction between carbon and oxygen is exothermic. What does exothermic mean? It means it transfers energy to the surroundings. So when energy is released, so it transfers energy to surroundings. Which is the correct reaction profile for exothermic? So the only one that's actually releasing any energy as the reaction progresses is this one. Okay, so the energy of the reactants is higher than the energy of the products, reactants, products, and this is the same, so it must be that one. Next one, a bit of calculations. The percentage by mass of oxygen in carbon dioxide is calculated by the equation here. Calculate the percentage by mass of oxygen in carbon dioxide. So what we've got to do is there are 2 atoms of oxygen. So you can see here, look, there's 2 atoms of oxygen. Times that by 16, because obviously that's the relative atomic mass of oxygen. And then we're going to divide it by the MR of CO2, which is where we add up all the top numbers of the elements in the compound. So it's 32 divided by 44 times 100, and the answer is 72.7%. That's that. If you need any help, ask your science teacher to go through that with you. So next one. Hydrogen peroxide decomposes to produce water and oxygen. Balance the chemical equation. So here we have obviously 2 oxygens over here and plus 1, that makes 3 oxygens over here. So there's 3 over here and then there's 2 over here. Now we can't change the little numbers, so obviously we'd just have to put a 2 here, and now we've got 4 oxygens over here. Okay, so that 2 oxygen times 2, so 4. So over here we're going to need, well, there's 3 oxygens over here. So if I put a 2 here, there's now 4 oxygens over here because 2 times 1 and then plus 2. So there's 4 oxygens over here now, and actually we've also managed to balance the hydrogens as well, because there is 2 hydrogens here, but times that by 2. So there's 4 hydrogens over here, and there's also 4 hydrogens over this side. So you've got to make sure that the number of atoms on the left is always the same as the number of atoms on the right. If you still need help with any balanced equations, ask your science teacher to go over it with you. If in doubt, sometimes it's a 2 and a 2 that works as well, but that's just a risk. Next up, 6.8 grams of hydrogen peroxide, that's hydrogen peroxide, decomposes to produce 3.6 grams of water. So we've got 6.8 grams going to make 3.6 grams plus oxygen. So calculate the mass of oxygen produced when 68 grams decomposes. So if we just do a simple calculation, conservation of mass, 3.6 plus something equals 6.8. So we know it must be 3.2 grams. And over here, if 6.8 produces 3.6, 68 must produce 36 and also 32, because they've times it by 10. Alright, so times it by 10, so the answer is 32 for 2 marks. Alright, again, if you need any help, ask your science teacher. Question 2, a teacher demonstrated the temperature change when hydrochloric acid is added to sodium hydroxide. This is the method they use. So, the measurement, what piece of equipment would they use? Apologies for that. So, what piece of equipment would they use to take the temperature of the solution? Well, we all should know that a thermometer would be used to take the temperature of a solution. The volume of hydrochloric acid, you would use a measuring cylinder, not a balance, obviously, not a beaker, because beakers aren't accurate enough, but a measuring cylinder. Next one, the teacher did the experiment 4 times. The table below shows the teacher's results. Calculate the mean maximum temperature rise. Do not use the anomalous result. Now, it's actually told you that, do not use it, so there is one. Now I'm thinking this one looks like it doesn't quite fit the pattern because 6.1, 6.1, 6.4, 7.8 doesn't quite fit the pattern. So therefore you do 6.1 plus 6.1 plus 6.4 divided by 3, and you get an answer of 6.2 for 2 marks. Next one, how could the accuracy of the experiment be improved? You need to tick one box. So add 20 centimetres cubed of hydrochloric acid. Well, that's not really going to improve the accuracy. Use a lid on the polystyrene cup, use a metal beaker, use a thermometer with a resolution of 1 degrees. I would use a lid on the polystyrene cup because that's going to stop the actual, use a lid on the polystyrene cup because that's going to stop any energy from being released, so therefore it'll create more accuracy in your results. The reaction between hydrochloric acid and sodium hydroxide is a neutralization reaction. The reaction produces a salt and one other product. Complete the word equation for the reaction. Hydrochloric acid plus sodium hydroxide. You make, this is the rule, so sodium is the metal in the base, so you're going to make a metal salt, so sodium. You're always going to make water when you add together an acid and a base, so acid plus base makes salt and water. So the name of the salt comes from 2 things. The first name comes from the metal in the base. The second name comes from the acid that you've used, and because you've used hydrochloric, you make chloride. So sodium chloride plus water. And again, if you're not sure on your salt rules, go over it with your teacher or maybe at home. Universal indicator is used to measure the pH of solutions. Hydrochloric acid is pH 1 and sodium hydroxide is pH 13. If you have a pH 1, you're going to turn the universal indicator red. And if you have a pH 13, you're going to turn the universal indicator purple. Next one, a student investigated the reaction of magnesium with hydrochloric acid. A piece of magnesium was dropped into the hydrochloric acid. So the reaction is exothermic. What measurements, so you can see the reaction there. What measurements would the student make to show that the reaction is exothermic? Well, you need to prove that the temperature's changed. So you need to take the temperature at the start and then you also need to take the temperature at the end, because you need to prove that the temperature's gone up, because then it's exothermic. So the temp at the start and the temp at the end. And how would these measurements show? Well, it would increase. I'm going to put temp would increase actually, just to show you only get 1 chance in that exam. And also the examiner needs to know for definite that you understand what you're talking about, so temp would increase, not just increase. The student investigated how changing the concentration of the hydrochloric acid affects this reaction. Each test tube contained a different concentration of hydrochloric acid. The diagrams show the results. So it's asking you to suggest one control variable. Now, a control variable is something that needs to keep the same. So it's something we need to keep the same. So for example, you would keep the volume of acid the same. You don't want different amounts of acid. Or you could say the temperature of the acid, because temperature may have an effect on the rate of reaction as well. Or even the size of magnesium ribbon. Which test tube, A, B, C or D, contain the greatest concentration? Well, if we look at the reactions here, they're using bubbles to show obviously the reaction and the hydrogen being produced. This one here, B, looks like it's got the biggest reaction because there's more hydrogen being released. So why did you choose that test tube? Faster rate of reaction. The faster the rate of reaction, the faster the rate, obviously, the greater the concentration. So why did you choose that one? Because it's a faster rate of reaction, so therefore must have a greater concentration. Next one, tick 2 statements in the table which explain why the student predicted that if the temperature of the acid was increased, the reaction would take place faster. So explain that prediction. This is because the particles move faster if you increase, if the temperature is increased. Also, they will collide more often. So if you increase the temperature, the particles are going to move faster because they've got more kinetic energy, and they're going to collide more often. And obviously, with more energy, not less energy, more energy because you've increased the temperature. Particles don't change size, big or small. They're the same size, but they will either have more energy, or if you decrease the temperature, they'd have less energy, but they're increasing. So increase the temperature. So they're going to move faster, they're going to collide more often. Next up, they're showing you this investigation. A student investigated the amount of energy released when 4 different makes of plain salted crisp were burned. I'm sure you've done this experiment before where you've burned a crisp. So the following method was used to make was used for each make of plain salted crisp. The pieces of crisp were all the same size. So the starting temperature of the water was measured, the piece of crisp was burned underneath the test tube, and the final temperature of the water was measured. So the results are shown here, and this is a bit of a hint. If they've got one here, they're going to obviously ask you to work it out. So calculate the temperature rise for make 4. So we've gone from the starting temperature was 21 and the final temperature is 25. So it's gone up by 4. Quite nice and straightforward. Which make of crisp, 1, 2, 3 or 4 releases the most energy? Well, I'd say it will make 3 because it's gone up the most. So let's pull that in. So make 3 because it had the highest. Oh, you could also say biggest, but the highest temperature rise. Make 3, so therefore if it's the temperature's gone up the most, it's released the most energy. Next one, the energy needed by a student is about 9,000 kilojoules each day. One large bag of crisps states that the energy released by the crisps is 240 kilocalories. Calculate the energy of these bags of crisps in kg. So 1 kcal equals 4.2 kg. So therefore, if you've got 1 to 4.2, you're going to have 240 so times it by 4.2, 1008. So just use your methods in maths as well. This can cross over 1008 kilojoules because 1 to 4.2, 240 is to 1008. Eating too many crisps is thought to be bad for your health. Use the information above and your knowledge to explain why. They have a high energy content, crisps. Good for a snack in the day, but not all the time, because they have a high energy content, and therefore, if you are not burning that energy off, the energy is going to be stored as fat. And then obviously you're going to become overweight, and then obviously you're going to have health issues. Or also crisps, you could also say, contain salt. And that's not good for us because salt, or too much salt, we should say, causes high blood pressure. Or kidney problems, because obviously your kidneys have to filter your blood. And there's the answers, and I hope you've done all right. And if you haven't, take your exam paper to your teacher, and maybe they'll be able to go over it with you a bit more slowly or in a bit more depth. Thanks for listening.